in today's class also we are going to continue with the revision that we were doing yesterday. The question from the chapter that we are going to start, the chapter's name is chemical bonding and molecular structure. The question that we are going to do is this one. The question is saying that draw the Lewis structure of following molecules. Molecules and ions. The molecules and ions are H2S, SiCl, 4, BeF2, CO3 2 minus, HCOOH. So the first structure they have asked us to draw is of H2S. Now they've asked us to draw Lewis dot structure. The central atom in H2S is sulfur, have 6 electrons in the valence shell. 1, 2, 3, 4. Let's try to draw this in this way. 1, 2, 3, 4, 5 and 6. 2 hydrogen atom will each give 2 electron and thus will form this structure of H2S, in which all the atom having their octet filled and doublet filled for hydrogen. Sulfur have 2 lone pairs, 2 bond pairs comprising total of 8 electrons, and hydrogen total comprising 2 electron each. The next molecule they have asked us to draw, the Lewis dot structure they have asked us to draw, is silicon tetrachloride. Silicon have 4 electron in its valence shell. Each chlorine have 7 electron in its valence shell. Each will give 1 electron, each will share 1, not give, each will share 1 electron with the 1 electron coming from silicon. 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the Lewis dot structure will look like this. Each chlorine will have 3 lone pairs, and we have to represent those lone pairs because in Lewis dot structure the electron densities should be represented, whether the electron density is in the bond density, therefore we have to represent the bond. If the electron are situated remain in the form of a lone pair, then we have to provide a dot to represent them. 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6. So the silicon central atom comprises 4 bond pairs, each comprising 2 electrons, total 8 electrons. So the octet is filled for silicon in this molecule, and for each chlorine 3 lone pair comprising 6 electron and 1 bond pair comprising 2 electron, total of 8 electron also present in each chlorine. So all the atoms in this silicon tetrachloride have fulfilled octet. The next molecule they have asked us to draw Lewis dot structure is beryllium fluoride, BeF2. Beryllium is the central atom. Beryllium is group 2 element, comprises 2 electron in the valence shell. These are the 2 electron of beryllium. Fluorine atom has 7 electron in its valence shell. 1 electron from out of the 7 electron, fluorine share that electron with the beryllium, with the electron coming from beryllium. There are 2 fluorine, so there will be 2 sharing, and thus the formation of beryllium fluoride is done. So the Lewis dot structure will look like this. Each fluorine comprising 3 lone pairs and 1 bond pairs, total of 8 electrons, and beryllium each comprising 4 electrons do not have a filled octet, but still this is a stable molecule. The next ion, the Lewis dot structure of the next ion that we are going to study is CO3 2- carbonate ion. Carbon this is the structure of carbonate. Each oxygen having a minus charge share 1 electron with one of the electron from carbon. Thus, there are 2 O- oxygen having 7 electron in its valence shell. By sharing 1 electron out of those 7 electron with the one of the electron coming from carbon, and the remaining 2 electron from the carbon is shared by 2 electron coming from a neutral oxygen atom. Thus, this bond is being formed. Thus, this Lewis structure is being formed. This entire structure of carbonate is according with the Lewis. Thus, O minus oxygen 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6. The last one is formic acid, HCOOH. Carbon, oxygen 1 2 3 4 5 6, hydrogen 1, and oxygen 1 2 3 4 5 6 7 8. Thus this structure, Lewis dot structure, will be a double bond between oxygen and carbon, having oxygen having 3 lone pairs 1 2 3 4 5 6. I have given too many numbers of lone pairs. There will be 2 lone pairs because the remaining 6 electron of oxygen has been shared with the carbon. Oxygen 1 2 3 4. This is the Lewis dot structure of formic acid.